Okay, this is lesson 3-3, and the topic is parent functions and transformations. So we're going to learn, specifically, we're going to talk about two types of functions today, and they're functions you've seen before, but you need to be able to recognize them whenever you see a variation of that function. So a family of functions or function family is a set, this should be of functions whose equations and graphs have a similar form and shape. So when you look at the first three, you see their lines. So these are linear functions. And when a graph has a V shape, you should just recognize right away, we've talked about these. These are absolute value functions. A parent function is the simplest function of the family. So give the parent function for each function family, then graph the function. So for a line, the parent graph is f of x equals x, or if you saw it as y equals x. So you could make a table of values if you wanted to. Whatever x is, y is. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2, etc. Or negative. If x is -1, y is -1. If x is -2, y is -2. So you end up getting a line that looks like this. That is your parent graph for a line. Now, this actually has a special name. It's called the identity function. And if you think about it, whatever identity x has, y is the same. So it's the identity function. An absolute value graph, we have f of x equals the absolute value of x. Now, if it hadn't been for the absolute value signs, it would be a line just like y equals x. So when x is positive, so we saw in class earlier when we looked at these functions with table of values, if x is 0, then f of x is 0. If x is 1, then y is 1. If x is 2, y is 2. But if x is -1, you take the absolute value of -1 and you get 1. If x is -2, the absolute value of -2 is 2. So you end up getting a V shape, and this is the absolute value function. So these are our two basic parent functions or parent graphs for a line and an absolute value. Now, I want to kind of talk, you know that this is a slope of 1. So if we put it in slope-intercept form, the slope is 1, the y-intercept is 0. So with a slope of 1, you know you're going to go up 1 over 1, up 1 over 1, up 1 over 1, because that's the rise over run. This is the same way for absolute value. You're going to go up 1 over 1, up 2 over 2. So if you go up 2, you'd go over 2, or up 1 over 1. You continue to go up 1 over 1. So you can kind of see how that graph would work, except you have to go both directions. So pay attention to that, because we're going to talk about the movements of the graphs with some of our transformations. So now we're going to talk about a transformation. A transformation changes the position or size of a figure, and you did some of these in geometry class. Transformations can be applied to parent functions. So we're going to use the absolute value function as an example. You should get your calculator out. We're going to graph the following functions, and we're going to compare it to the parent function. So I'm going to graph the parent function first. Remember, if you go alpha and then F2, the window key, you'll see the absolute value. So we're going to put an X. To get an X, it's next. The shortcut key is next to the alpha. And we're going to graph that. I'm going to hit, I don't know how my calculator is set up. If I go zoom 6, it's going to be a standard viewing window. Actually, I'm going to change this. So you might want to change yours. -5 to 5 with a scale of 1. -5 to 5 with a scale of 1. Okay, so here's my graph. Now I want to compare that graph to number 3 where it says the absolute value of x plus 2. So I'm actually going to graph that in y2, and I'm going to graph the absolute value of x plus 2. So you'll see this. Now if I hit graph, so then what happened? So you can see my parent graph is in blue and my other graph is in red. And notice what happened. It looks like it got shifted to the left too. So it shifted left 2. So let's try the next one. So I'm going to hit y equals. Now I can actually make this change because now we want to change this to a minus. So just go over the plus sign and hit minus and it will just switch it for you. And then we can switch graph. So now the blue is my original parent graph, and notice that this looks like it got shifted to the right 2. So shifted right 2. So next we're going to do the absolute value of x plus 2, and notice the plus 2 is on the outside of the absolute value, so it's different. Think about it for a minute. What do you think is going to happen? So try and make a prediction. I know we haven't looked at those yet, but just think, okay, what might happen? So kind of get that picture in your head. What do you think might happen? So I'm going to, I'm just going to clear this. If you hit clear, that will clear the whole thing out. Start over. So alpha, hit the absolute value of x, and then you have to hit the right arrow so you're outside of the absolute value and plus 2. And I'm going to hit graph. Okay, is that what you thought might happen? So what happened was it shifted up 2. Now let's take a look at what happens for the absolute value of x minus 2. Make a guess. What do you think is going to happen? And let's try it out. So if I just switch this to a minus and hit graph, and notice that my parent graph now has shifted down 2. Okay, next, we're not going to add or subtract anything. We're going to multiply by 2. So I'm going to go down here, I'm going to clear this one, and I'm going to put 2 times the absolute value of x. And I don't know, maybe you have an idea of what's going to happen, maybe you don't, but I'm going to hit graph. Now this one's harder to tell, but if you look carefully, notice that on my blue line, if I start at my vertex, if I go up 1, I go over 1. And if I go up 1 again, I go over 1 again. I'm actually going to show you something. Hold on. If you go second format, and you go here to grid dot. And now let me hit the graph. This might help if you have the dots because we can count. So now on my blue line, my blue V-shaped graph, which is my parent graph, you can see up 1 over 1, up 1 over 1. I have that consistent slope of 1 going both directions. Notice the one in red. If I go up 2, I go over 1. And if I go up 2 again, I go over 1. So my ups are doubled. So what that means is this is a vertical stretch by 2. But I like to think of it as double the ups. That's not UPS. As in the company, double the ups. So up 2 over 1 instead of up 1 over 1. It's like having a slope of 2, except that it is in both directions to make your V, but it controls the steepness of the V. So now let's see, well, what do we think is going to happen if we make this a 1/2 instead? So I'm going to clear that out. You can do a fraction, alpha F1, you can make the fraction here. So if we have a 1/2, and then we want the absolute value of x. Okay, so think about what might happen. And here's my graph. Now notice that again, we know that the blue line, my blue V, was up 1 over 1. This one appears to be up 1 over 2, up 1 over 2. So this is called, when we do this, this is called a vertical compression. And it would be by a half. So we're going to think of have the ups. We're going to take half of that. So we're going to have the ups. So that it's a compression. Imagine if you had your V-shaped graph and you stuck a book or something really heavy on top of it. You're compressing it. So that's why it's called a vertical compression. And our last one that we're going to look at is what happens if we make this a negative in front. Actually, I probably need to make sure I use the negative sign. And then absolute value of x. So I don't know if you have a prediction, what you think it might happen, but I'll hit graph. And notice that I have this reflection across the x-axis. So this is reflected across the x-axis. So look through this just for a minute. Look through this and does anything surprise you when you look at these? Does anything seem backwards or wrong or anything? Just take a minute to look at that. So maybe pause the video and take a minute to think of what might surprise you. So one of the things you may have thought of, I think that number 3 and number 4 can be kind of surprising because, you know, we get this +2 at the end shifts it up because it's a +2. Shifts it down, it's a -2. So you might look at this though and say, why did it shift to the left? Because there's a +2, doesn't it shift to the right? So if you remember when we found the vertex in class when we were doing a chart, we said to make x plus 2 equals 0, and then we solved for x and we got x equals -2. And it's a negative. That's the idea behind it, why it gets shifted to the left. So it's always shifted the opposite direction of whatever this sign is if it's inside with the x. So just something to watch out for. The shifting up and down, which are the vertical shifts, those are not surprising. The vertical stretch, that's not surprising, that's steeper and this is less steep. And even the reflection. So I think that the adding and subtracting one, when it's inside with the x, are a little bit surprising. So the types of transformations that we have a translation, and the translation is a slide or a shift for the function, and we have a dilation, and that is when it stretches or compresses, and then we have a reflection when it flips the function. Now, I'll be honest, I don't usually use the words translation and dilation that much. I will instead say like a vertical shift, or like 3 and 4 are horizontal shifts. Number 5 and 6 are vertical shifts. And then we'll have the stretches and compressions and reflections. So here are the transformation rules in general. And we're going to use function notation for this because this is not just going to be for lines and absolute value graphs. Later, we're going to look at quadratic functions and cubic functions and all different kinds of functions. And even when you go on in math, you'll look at different kinds of functions. And these rules are going to hold true for all the different kinds of functions we look at. So in general, when you have f of x plus h, this is going to shift left h units. If it's f of x minus h, remember it's opposite the sign, so we're going to shift to the right h units. If it's f of x plus k and that k is outside of your f of x, this is when it's going to shift up k units. And if it's f of x minus k, it's going to shift down k units. The dilations, if you have a constant times your function, if that constant, if the absolute value is bigger than 1, so like if you had a 2 times f of x, or a 3, or a 3.5 times f of x, or a negative 3.5, as long as the absolute value of that number is bigger than 1, it's going to be a vertical stretch. And if you have a vertical stretch, it's going to get steeper. If that value that's being multiplied by your function, if the absolute value is less than 1, like if it is a half or a third, it can be a decimal value that's less than 1, or it can be negative 1/4 or something like that, then you're going to have a vertical compression and your graph is going to appear to be wider or flatter. And if you have a negative in front of your function, negative f of x, that's when you get a reflection, or it's going to reflect across the x-axis. Now, what I'd love for you to do is pause the video and make some predictions. What do you think is going to happen to these? And fill it out and then come back. But I wouldn't know if you did that or not. So, but you could. So let's see, what do we think is going to happen if we have f of x equals the absolute value of x minus 3? And you could always check these out afterwards on your graph. But notice that this is the one where the 3 is on the outside. So this is like the f of x minus k. So that means this is going to shift down 3 units. Number 11 is like our first one up here, f of x plus h. So this is going to shift. Remember, it goes opposite. So it's going to shift to the left 7. This one's going to do two things. This right here, the negative sign, is going to make it reflect across the x-axis. And this minus 4 is going to make it shift. Remember, it's opposite, so shift to the right 4. So it's going to do two things. This one also, two things. This 4 out front, vertical stretch by 4, so it's going to be steeper. This plus 1, it's going to shift up 1. It's a vertical shift. Again, you can check this out on your graphing calculator. If you were going to graph this, oh, well, we'll talk about this in a minute, the vertex. We'll look at that later. This one is going to be, we're multiplying by a fraction that's less than 1. So that's like this second dilation. So we're going to have a vertical compression by a third. So it's going to be wider or flatter. This one's going to do two things. Think about what this plus 2 inside the absolute value is going to do. It's going to move it to the left 2. And then this minus 5 is going to move it down 5. Actually, I'm going to use this one as an example of this. If you remember our parent graph, if you look at the vertex of our parent graph right here, the vertex is 0, 0, the point of our V, 0, 0. So imagine if I were to move that, like this one says to move it to the left 2 and down 5. So that means my vertex is going to get moved to the left 2 and down 5. and my new vertex would be here. So this is a way, when you have a transformation, you can actually locate the vertex. The opposite of this, which is going to be a -2, because we went to the left 2 and down 5. So it's really important with absolute value graphs to be able to know where the vertex is. If you remember when we were doing it with a table of values, we put that at the center of our table because it was really the most important point. We call this the locator point. So this is kind of the locator point for our V when we're going to draw that. We want to know where that goes. So when it's written and you can think about what the transformation is, you can actually just write down what the vertex is from looking at that. All right, on the next one, we have actually 3 things going on. This negative sign reflects, except that's not how you spell reflects. Reflects across x-axis. The 2 is a vertical stretch. By 2. And the -1 is going to shift to the right 1. By the way, my vertex is not controlled by my stretch or my reflection. It's only controlled by shifting left or right or shifting up or down. So if I shift to the right 1, it was at 0, 0. Now it's going to be at 1, 0 because I'm not going up or down. You don't have to do the vertex on these, but I thought, we may as well talk about it. Okay, this one, notice that this fraction is bigger than 1. So that means it's going to be a vertical stretch. By 4/3. And this +2 is going to make it go up 2. And the last thing we're going to do on our notes is, what if you had the words and you have to say what would the equation look like? So if you were going to go 7 units to the right, think about where that means. I'm going to have to place, if I'm going 6 units to the right, then f of x, that means my 6 has to be inside and it has to be the opposite. So this would be 6 units to the right. Number 19, if I reflect in the x-axis, so reflect across the x-axis is what I would normally say, and then translate 2 units up. So if I'm going to reflect it across the x-axis, that means this has to be a negative. 2 units up means the +2 is going to be outside of my absolute value. Number 20 says vertically stretched by a factor of 5. So that means I'm going to have a 5 in front of my absolute value, translated 1 unit to the left, which means the 1 has to be inside with an x because that's when I'm shifting it left or right, and it's going to need to be a +1 because it has to be the opposite sign. Translated 3 units right and 4 units down. So it's not vertically stretched or compressed, so I don't need a number out front. There would be one, by the way. It'd just be a 1. So if I'm going to go 3 units to the right, I need the opposite. So x -3 would be 3 units to the right, and 4 units down means I'm going to subtract a 4. 22, vertically compressed by a factor of 2/3. So if it's compressed by a factor of 2/3, and I'm reflecting across the x-axis, so I'm going to have a -2/3 absolute value times the absolute value of x. So I have my factor of 2/3, but I'm going to make that a negative since I'm also reflecting it across the x-axis. Next, we're going to vertically stretch by a factor of 2. So my 2 is going to be multiplied out front, then translated down. So that means there's nothing in the absolute value with the x. It's not shifting right or left. It's just shifting 9 units down. And for the last one, it's vertically compressed by a factor of a 4th. So that means I'm going to need a fourth. And I'm shifting 1 unit to the left. Left or right means it's inside with the x, and it's the opposite. So left is going to be a plus. So we're going to have x plus 1. And that is it for our little intro to our family of functions and our transformations.